Welcome back. So in the last few videos, we've been spending a fair bit of effort getting our data into an accessible format. Now we've got that. So let's just quickly have a look. We've got Boolean labels, which is our labels in numerical format. We'll have a look at the first two so it doesn't take up too much room. There we go there, true and false. We can access those as zeros and ones really easily. And the same goes for our file paths. So these are our training images here. And we left off discussing how Kaggle doesn't provide us a validation set. So creating our own validation set. And so since the data set from Kaggle doesn't come with a validation set, we're going to create our own. And remember from way back in Machine Learning 101, the most important concept in machine learning is the three sets, aka the training set, the validation set, and the test set. So right now, we've got the training set and a test set. But we'd like this validation set, which is aka the practice exam. So to reiterate, we'll train our machine learning model on the training set. We'll evaluate it on a validation set to see if our experiments that we've been doing on the training set are going all right. And then finally, the final exam is our test set. So we'd like this little intermediate set to validate our initial experiment. So that's why we're going to make a validation set. And now to do so, what could we use? What have we used in the past? I want you to think about this. It was in the scikit-learn section. If you said train, test, split, you'd be correct. Now, it can be a bit confusing because it says train, test, split, but really the functionality of the function is just splitting data into two different sets, one set of certain size and another set of another size. Let's set that up. But first, what we might do is set up X and Y variables. Now, the reason we do this is because having to remember Boolean labels and file names is a bit tedious. So what we might just do is create X, which is our standard variable for your data, and Y, which is usually the standard variable for your label. So we're just going to make copies of those. Beautiful. And now, since we're working with 10,000 plus images, 10,222 to be exact, it's a good idea to start working with a portion of them first to make sure things are working before we go and train a machine learning model on all of them. This is a thing to note for your own projects, is that when you're doing experiments, remember, what's our goal? It's to minimize the time between experiments so we can figure out what works and what doesn't. And if we're using 10,000 examples every single time, that's going to take a while. And if you've never trained a machine learning model or a deep learning model on 10,000 plus images, so you don't have a perspective of how long that takes, you can take my word for it that it would take a long time. So we'll probably reduce it down and start with about 1,000 images to begin with and then increase it as we need. So let's write a little note for ourselves. We're going to start off experimenting 1,000 images and increase as needed. Now this goes for not just images, but for all kind of machine learning projects. And we've seen this in the past using subsamples of our data. If you're working on a text classification and you had 100,000 emails and you wanted to classify whether they were spam or not spam, you might only start with 5,000 and then build up from there. So let's set a little parameter. So set number of images to use for experimenting. Now, I want to show you something really cool within Colab. So we'll create a little parameter here. And now it's in capitals because a convention you might see here and there with deep learning projects is that hyperparameters, so things that you can set as a user, are often set in capitals. That's where you might see these variables that are in full capitals. So let's go 1,000. And then in Colab, it has this little cool tool that you can, it's like a magic function at param. And now I'm still working these out. So maybe you can leave a a little suggestion on where I can find out how to make more of these if you figure it out, because I only know a couple. Now watch this. So what we've done is we've just gone, hey, this is a parameter that we can set, create a type slider. The minimum is 1,000, max is 10,000, and the step is 1,000. Num images has now just appeared. Look, if we go like this, oh yeah, 5,000, 5,000, 8,000, 8,000. Well, I could play around with that all day. That's something that Colab has over Jupyter, aside from being backed by a GPU for free. All right, so now we've got a little parameter. We've got X and Y. Let's use scikit-learn's train test split. So let's split our data into train and validation. From model selection, import train test split. Now again, this is called train test split, but the basic functionality of this function is to split. You could do this manually by using indexing, but we'll just use a function to help us out. Is just to split data into two different sets, into training and validation of total size num images, which is this variable we've set up here. Run that cell. Xtrain, xval this time, not xtest, ytrain, yval equals train test split x up to num images. So it's only going to take the first 1,000 file names, because remember, x is just our file names. We haven't imported our images just yet because it's a lot faster to work with just file names. And y is our labels in Boolean form. Test size, again, this is just validation size, will be 20%. And then the random state is kind of like setting random seed. Well, it is like setting random seed to 42. So random state equals 42 is the same as going np random seed 42. And if you're not sure what np random seed does, there's a video on that. Otherwise, you might want to just quickly Google what does np random seed do. So if we go len xtrain, just to check all the lengths of our data are correct, because you wouldn't believe the amount of times I've been burned because my data was the wrong shape. You will spend hours battling to get your data into the right shape. Trust me. I've been there. All right, wonderful. So we've got 1,000 samples and we've got a 20% test size. So that means there's going to be 800 samples in the training split and 200 samples in the validation split. So let's just have a quick look. Let's have a gaze at the training data. So xtrain, just to verify that we're still on this earth, we're still working with the right stuff. Actually, that's a bit too many. I've got to remember that these are full-blown Boolean labels, so there's a lot there. So train, we've got file paths, correct, that is what we want, and training for labels, we have Boolean labels. That is what we are after. All right, so now that we have our data into a training and a validation set, a small subset, mind you, because remember, our goal to begin with is to minimize time between experiments. What we can probably finally do is turn our images, or at least create some functionality to turn our images and labels into tensors. Let's do that in the next video.